Good afternoon, everyone. Welcome. This is my, I think, fifth or sixth Strata. It's really good to be here. This is one of my favorite conferences. I'm honored to be joining the ranks of so many awesome people. So what are we going to talk about today? We'll talk about continuous delivery, and I'll very quickly address why continuous delivery and not something else. And we'll talk about why Kubernetes is such a good fit for that. And I want to take you through the top 10 lessons that I learned implementing continuous delivery on Kubernetes for an NLP product. So just a quick disclaimer. I currently work for Google. I previously worked for Cordova. I've been at Google for a few weeks, not very long, and so this talk is going to mostly be about the work that I did while I was Director of Data Science at Cordova. And just to give you a very brief, I want to touch on this very briefly, continuous delivery, subtext, why not continuous integration, continuous deployment. So continuous integration is related to merging code on very frequent bases, and that is part of continuous delivery. So is continuous deployment. I'm using continuous delivery as an umbrella term to refer to all of those, because if you try and search for continuous deployment, you don't even get a did you mean continuous delivery. You just get straight into the continuous delivery slide. So Wikipedia and Google, they all send you there. Continuous delivery is really just an umbrella term. Take it to mean what you will. For me, it means sort of everything involved in the process. So why do we care about continuous delivery? Lots of reasons. Number one, it saves time. This is engineering time. This is data science time. This is DevOps time. This is maintenance. Lots of different times. It results in more robust and more resilient systems because so much of it is automated. There's a lot less maintenance involved because you can script it out. You can do things ahead of time instead of having to fix breakages. You can manage a lot of that beforehand, and it results in better products, higher quality platforms. So what does Kubernetes have to do with all of that? Well, let's go back to this Cordova thing. So a little bit of background on myself. Both my degrees are in computer science. Most of my early career was in a data engineering role. And the past few years, I focused on multilingual NLP technologies. So Cordova was a platform to help people internationalize their software, to make products feel native to every user, regardless of their language. And it had a very typical microservices architecture. It's a B2B SaaS platform with a front end for users, lots of integrations with different services, and an orchestration layer that ties all of those services together. So when I came in as head of data science, my mission was to create an affect detector. And what that is, it's similar to a sentiment analyzer, but it goes a little bit further. And the goal is to be able to understand the emotion associated with a piece of text. And this was really critical for this internationalization platform for automating a lot of that process. So before I got there, everything was running in Mesos. Cordova is a big Scala shop, and it was already pretty automated. A lot of jobs would put together all of these jar files and copy it into this Mesos cluster, and it was all very well organized, very clean. The repos were all pretty standardized, but it wasn't really the place to put an affect detector. So when I got there, trying to add some NLP to that was a little bit difficult. But what I started out doing is just building a Docker image with everything I needed. And so there are a few components. When you're creating a machine learning product, there's your data ingestion phase, there's the cleansing, you store it somewhere, you do something with it. You then need to train it. So all of the code to turn it from text into numbers, all the featurization steps, all of that needs to be in there somewhere. You train it, you deploy it, and then you can serve up predictions. So these are all very different types. When you deploy them, they look very different, but you need to use the same code in order to have consistency between all of these steps. So what I did is I built a single Docker image with all of those pieces, and created different entry points for each of those tasks that have very different footprints. So there was the data load component, that was one piece. There's the training component and the serving and prediction. Now this makes a lot of sense in a Kubernetes environment. It makes a little bit less sense in the existing Mesos environment. It wasn't just this nice, neat jar package that this jar file that I could package up and deploy alongside the rest of the typical web architecture. So what I did is I put it into a Kubernetes cluster. And part of the reason why I joined Google is because I spent so much time working with Google Cloud Platform products. So I started out with managed Kubernetes. This made the most sense to me. And I took each of those entry points. I created a container out of it. And using the same image, I created Kubernetes objects, which is essentially just writing configs for them. And I created one little data science cluster. And essentially gave the rest of the platform a REST endpoint for accessing that. So that meant that anyone coming from the platform could send some text in and receive a prediction. And it didn't really matter where it was running because they had a REST endpoint. So there were lots of different pieces to that. It was pretty easy to scale out. It was easy to add phases when featureization changed or when we added new languages. Because it was in the Kubernetes framework and I already had all the endpoints, it scaled very easily. And once I had that ready, so this is what it looks like. So regardless of how many containers you have, it's really easy. You can just add more nodes and you don't really have to worry about it. But the thing about it, when I presented that endpoint to the rest of the team, they were kind of like, wait a minute, how did our head of data science just go and deploy all this code? Like, there must be something to this. It must be a little bit easier and less complex than we thought it was. And they were right. And so what we ended up doing with the rest of the platform is containerizing everything and putting it alongside all of the data science code. And it was pretty simple to do that, pretty straightforward. Because all we had to do, we were using managed Kubernetes, so we added a few more nodes and we added wrappers around each of the jar files that we were building previously. So we Dockerized everything and started running it all in the same cluster. And that solved a lot of problems for us. One of the biggest lessons we learned is instead of splitting things out and having like a data science cluster and an engineering cluster and whatever else cluster, just putting everything in one place was pretty huge. One of the biggest reasons that made sense is networking. Kubernetes has a really interesting networking solution. If you're interested at all in networking, you should go read about it because it's really cool. But essentially, none of the services have to care about port conflicts or where anything is running. It just knows that I need something from the front end. So I'm going to call front end on port 80 and I'll get a response back. And so no matter how you scale up and down, no matter what changes you make to your cluster, your services can always talk to each other. And that's a big pain point in other environments. With Kubernetes, you really don't have to think about it. It gets rid of, and networking is one component of that, but in general, it's a lot more simple to run because you're just creating configs for each one of these services that you want to run. You're defining the resources that you need, and there's a lot less code involved, and there's a lot less overhead in getting things to talk to each other. The other thing we really liked about it is the ability to standardize across microservices. So if you're deploying things in the same environment, then you can write scripts and you can build tools that don't care what that service is. They'll deploy them in the same way. And so you can abstract out a lot of the sort of service-specific things. And that ended up being really, really simple for us because we could stand up an entire cluster. So the entire platform, we could stand it up with just a single script, which turned out to be really good for our what was it called? Some sort of certification that we were going for. That was really key for it. So being able to stand up an entire new environment in very little time and without any manual effort. The other thing is that these are all heterogeneous pieces. These are all very different pieces, and what it does is it gives people the freedom to run anything they need to in the same environment. And that was really important because data science and engineering don't always do the same thing, and everyone likes to work with the tools they need, and that gives people the freedom to, if we come in and have some other really interesting key part of the platform, you don't have to worry about, oh, but you don't fit into the Mesos cluster we have, like go do your own thing. It's a lot easier to run everything if it's all in one place. Another big lesson is to put everything in source control. Back to the whole standing up an entire cluster in just a few minutes. This is really helpful for that. So the thing we discovered is that it helps you a lot if you can draw a very clean line between your persistent and ephemeral components. And the more you can put in source control, the cleaner that line is. So what we saw happen was some servers accidentally get shut down and then get rebooted, and with different IP addresses, we sort of discovered where things were hard-coded. But we also discovered that we hadn't been backing up servers in a while, so we had to recreate things. And so we moved to putting everything in source control. So your Jenkins file, how do you write your build jobs? You may think it's pretty straightforward, especially if we've standardized across microservices. But actually rebuilding those Jenkins jobs is a total pain. So just having Jenkins files that lives inside every repo was really helpful. Same with Docker files, containerizing everything. The more you can keep in one place, the better. And then also just our Kubernetes configs themselves. So how are we deploying these? What resources do they need? What are the networking specifications? All of the deployment specific things. That had its own repo as well. And we used these ephemeral tools to pull that in, but we would pull it in at runtime. And that meant that we weren't losing anything if servers went down. It basically allowed us to use VMs and throw them away and not worry about the time it would take for us to recover. So there's one icon here that you probably don't recognize, and that's Weaveworks. And that was the thing that would sort of watch our container registry to see when new, I should probably back up. Let's start from the very left, where you have an engineer, a developer, a data scientist, whoever. They're making a change, and so they merge a PR, they commit some code, they push it out, and Jenkins basically watches for that, sees that there's a change, automatically builds a new container, pushes it into the container registry. The Weave was the component that was watching the container registry, and when it saw that there was a new image, it would do two things. It would update the version number in our Kubernetes config, so it would tell Kubernetes there's a new version available, and then it would actually push it out to the cluster. So we had all of these hooks watching those persistent stores, and when anything changed, it would automatically deploy it. That was really, really useful. And that's the third lesson, is just that the more you can automate, the better. Sometimes bots are better than people. So this whole workflow, this is referred to as GitOps. If anyone knows, I think Alexis Richardson, I'm not sure if he coined the phrase, but he has some really good blog posts that describe it. He's one of the co-founders of Weaveworks. And really the idea behind it is just that for your DevOps, you're putting things in GitHub. So anytime you're changing a configuration parameter, you change it by committing code. So you push a change to your repository, and then there's something that's watching for it and actually does the deployment for you. And the really nice thing about that is that you have a long history of what's changed in your environment. You can see what works, what doesn't, and it's a lot easier to go from development, staging, production, because you know exactly what's different between your environments. And so the other important component is testing. If you want to automate, you don't want to just be pushing changes out and then deploying it if you don't have some sort of quality gate to tell whether you've broken something, whether you've improved it. And that's where testing comes in. You're probably all familiar with unit tests and integration tests, but something that I learned at this Strata is pipeline tests. And there's this new tool called Great Expectations. I threw that up here as a bonus because I really liked what I saw. So it's a way of testing your data and basically baking that into your process so that when your data changes, you still have that quality gate. That's a tool that I haven't seen anywhere before, so I'm really excited about this new project. But tests are really key for being able to automate this whole process. So automation is good.
Was that pipeline test, the Great Expectations does pipeline tests?
That's correct. The question was whether Great Expectations does pipeline tests. And I have a GitHub link later on. It's open source. One of the creators is sitting right in front of you, Abe Gong. And they have some really good videos online. There's a bunch of information. It's pretty well documented. So the next lesson is to empower your people. So bots are great, but they should be doing the things that you don't want your people doing. You want to free them up to be able to do the hard things. And what I really, really liked about the whole concept of GitOps and enabling really anyone to just push code and see it live, I really liked that it solved a big problem of conflict between data science, engineering, and DevOps. That's a conflict that I've seen over and over and over in so many companies, and this process was incredible. So moving our entire platform over from Mesos to Kubernetes, it's a huge project, but it was very much driven by both data science and engineering, and there was zero friction. It's like everyone agreed that it was the right direction to go in. We had full support from DevOps. It just made everyone's lives easier, and it was so nice to see that collaboration. And the end result was that no one had to ask for anything because people were empowered, and that was a huge benefit for us. The other thing that we learned is that if you don't need to manage it yourself, you really shouldn't. For me, especially, managed Kubernetes is by far my favorite tool on GCP. And I learned a lot about, when I started looking into this, I started talking to a few friends who had been using it. And they just had all of these battle stories, like there were visible scars from their battles trying to do things on Kubernetes because they were maintaining their own clusters and they were dealing with like forking the repo and standing it up from scratch. And I had none of that. It took me a while to realize why I thought Kubernetes was so easy and everyone thought it was so hard. And that extends to other tools as well. There are a lot of reasons why you might not want to, and a lot of them are justified. But if you look at the actual cost in terms of, not just developer costs, but like long-term maintenance costs, those edge cases aren't always worth it. So just really think very carefully before you pass up a managed solution, because there are trade-offs to using it, but in our experience, it was more than worth it, and it resulted in some really good habits that will pay off down the road as well. So that goes for not just Kubernetes, but these are, I think, these are most of the tools that we used at Cordoba. There's Cloud SQL, there's storage, Bigtable, PubSub. There are a lot of different services, and whatever you need, there's probably one out there. Just look at it first before you decide to roll your own, because it really allowed us to iterate faster. So another important lesson is just make sure that you can bring it somewhere else. We were very careful about choosing open source tools that didn't tie us to the platform. And the advantage of that is just that, not for bringing it to another platform, but if you ever need to go on-prem, if you want to work locally, there are a lot of reasons why you might want to take your code and put it somewhere else. It's entirely possible to do that. We did that with almost everything. And it may not be possible to do with everything, but if you do have to move somewhere else, then it can make that process a lot easier. So another important lesson is to version things, because if you're using GitHub, if you're automating things, that means you can deploy them quickly. You also want to be able to roll them back quickly. And there are a couple ways of doing that. The way Cordoba solved that was by using Prediction.io as a serving platform. And that's sort of baked into the framework. But this is another thing that I heard about at this Strata that I wanted to share. And it's called Quilt. This is a way of versioning your data. So it's kind of like Docker for data is the way they describe it. But it's a way to keep track of the data that you've used with models. So you're not just versioning the models themselves, but you're versioning the data that goes into those. which can be very difficult to manage. So those are a couple of solutions. But whatever you do, just version it, keep track of it, because otherwise it's really hard to untangle. And if things go wrong, you can't necessarily even pinpoint. You might not be able to get back to the place you were before. Another lesson is to store everything. Your models, obviously, if you're versioning them, you're storing those, but what you're putting into those models, don't just add your positive training data, add negative examples as well. And keep track of which ones go into which model. If you don't have that, you can get it. Add some feedback to your UI. Find ways to get more data, to get more training data, because you can always go back, and once you've deployed a model, you can make it better by figuring out, essentially asking your users, is this useful, is this helpful, or finding creative ways of somehow evaluating how good your models are. The other thing you want to keep track of for evaluating how good your models are, metrics. As many metrics as you can think of. And how do you do that? Well, you log. You log everything. You want to log the full stack trace. With Kubernetes, it can be a bit difficult to sift through where things went wrong and when, but if you have metrics, you can pinpoint where it went wrong. If you have a full stack trace, it's easier to find the place in the code where that happened. And if you're versioning things, then you can roll back to an exact place and time, figure out where the bug was, and rerun things, hopefully with maybe better training data, and come up with better models. But that's a way to, the more you store, the more you can do with it. And even if you don't think you'll use it, store it anyway, because it could come in handy down the line. This one is, I feel like, a really underrated topic. So communicating progress is actually a really important thing, because it turns out there are a lot of people who care about the progress when you're at a startup. And if you're logging everything, if you're storing everything, if you're keeping track of metrics, then this becomes a little bit easier. It's a lot harder to communicate progress if you don't have concrete numbers to communicate. But it's really important to talk about the goals that you have and your progress in achieving those. If nothing else, for yourself, and to keep team alignment to make sure that everyone is on the same page. Which they will be if they're all working, if they're all empowered to deploy their own code. You want to be able to measure exactly what you've been doing and how well you've been doing it. You want to be able to show that you're seeing traction in whatever project it is. If it's open source, you want to be able to talk about new contributors, new downloads, that type of thing. And then just for transparency, so that people understand what you're doing and why. And again, this is not just for other people, but this is also for you to make sure that you sort of stay on track. That was really important because it's easy to go down rabbit holes with Kubernetes. There are a lot of things to get distracted by, and just that like weekly or bi-monthly alignment turned out to be really useful. So once you have everything set up and everything is running beautifully, don't stop. Keep improving and keep looking for things that you can replace as they serve your needs better. So the platform that we built out is lovely, but it's definitely not the end all and be all. And this is really just one example of a way of putting lots of different tools together. But there are thousands of combinations that you could use. Everyone has a different constellation that makes sense for them. And if there's a better solution, if you model it, if you separate it properly, then you should be able to just swap things in and out, especially if you're using managed services, then it feels it's less painful because you haven't invested as much knowledge and expertise into it. And I wanted to share something that I came across since we deployed this, and that's a project called Kubeflow. So when I set out to build this, it was kind of like, okay, out of the universe of tools that I could use to do this, which ones do I pick? And that was the combination of tools that I came up with, but that was a really involved and hard process. And there's this brand new, it's still a very young project, but some of the people who were involved in developing Kubernetes are on this project, and what it is, it's to solve that problem. It's for running machine learning products on Kubernetes. It's open source. It has a pretty active community so far. It has a lot of traction. But the idea is to kind of provide a menu so that you don't have to just pull things out of the air and decide and like try things out. You can sort of follow a reference architecture and like, okay, we know that these things kind of work together and here's how, and here's an easy way to make that work. So keep an eye out. Don't just get your solution together and then forget about everything else. And these are the links for the other two tools. You can't go see their talks because they were yesterday, sorry. But Great Expectations is the pipeline testing for data, and Quilt is the Docker for data that allows you to, it makes it easier to version your models and keep track of which data is used for which things. There's a lot more to it. That was just how they fit into, this is how I would have used them had they existed while I was at Cordova. But there were some really neat tools. So that was all I had. If anyone has any questions, I think we still have some time left. Feel free to shout them out.
You mentioned your contrast to Mesos, but it sounded more like the real issue was you were constrained in an Apache Mesos environment and you found a Kubernetes managed environment basically give you all the freedom that you needed. I didn't hear much about technology or technological reasons why Kubernetes or Mesos were different.
Yeah, that's a good question. So he's asking about the contrast between starting out on Mesos and moving to a managed Kubernetes environment. So that's right. The team was managing their own Mesos environment, and the technological reason for doing so, for migrating everything instead of moving to a managed Mesos environment, because it solved a lot of other problems for us. So we could have gone down that route, but we also wanted the communication. We wanted the networking, the simpler networking. We wanted to not be, I guess if we were moving to a new environment, it solved a bunch of other things too. And for us, that made the most sense. It's definitely an avenue to go down. I have no idea, I haven't used Mesos in a while, but like as a data scientist, it was the shortest path to, if you're in a startup, you're trying to get things out. And writing configs was a lot easier than trying to sort of forklift into a different Mesos environment.
Can I do a follow-up?
Sure.
Your points 5 and 6 were use it, don't do something if you don't have to, which is use managed environment. But then you said take it with you. And you mentioned on-prem, which is something we're discussing. Have you had experience, or how would you go on-prem with maybe something you can put into a shared environment, like a cloud environment for security or compliance reasons? You needed a Kubernetes on-prem. Have y'all looked at that, at how you would best manage a Kubernetes if you had to manage it yourself?
Yeah, so the question is, so I mentioned use managed if you can, but choose tools that you can take with you, and whether Cordova specifically looked at doing things on-prem. How would you go about that if you needed to, if you couldn't put something in the cloud? Startups generally don't do things on-prem, so that was not a consideration for us. Had we had customers that required it, it might have been, but then we would have gone out and gotten the expertise to stand up our own framework and actually done the Kubernetes ourselves. But that was a thing that we felt empowered to do should we need to, but not the pressure to. So it really just bought us that freedom to do so if we were pushed to it. It made us feel a lot better about using a managed solution. I think I saw another question. No, go ahead. ECS, is that Elastic Compute? Elastic Container? I have not. So my experience with AWS was that didn't exist actually when I was looking for this. So for us, the only option was GCP, and we were already in there. So I don't know how the two compare. I haven't used it. Do we build a beta and a production? Yes, absolutely, and that's a big advantage. So the question was whether we have models running in different environments and we compare them to make sure that the accuracy is high. That's exactly what Kubernetes buys you, because the more you automate it, and if you can just stand up a cluster with a single script, the more environments you can have and the more comparisons you can do, and you can automate those. So that was a huge advantage for this. Yes. Yes, there were separate clusters for each environment. I think some people use namespaces and they'll have one cluster and they'll just segregate it out by namespace. But if you're using managed, then you have the freedom to just spin up different clusters, and that's how we chose to do it in completely separate GCP projects. Any other questions? Oh, one back here.
So, because succeeding in selling engineering on Kubernetes from data science, which is usually the reverse way around. But previous to that, you actually sold it to fellow data scientists. How did that go?
Well, I was head of data science, so it wasn't that hard. No. I mean, we weren't huge, and from the beginning, actually. So I was the first San Francisco employee, and from the beginning, I was always very well integrated into the engineering team, and I was very specific about not having like data science versus data engineering. So it was a pretty collaborative. Like it was obvious, and there was not any contention about it really. Because it empowered so many things. It solved so many of the pain points that we were facing. We really didn't have to sell it. I'm sure that would be very different if you were at a large company. And just to repeat, the question was, how did I sell it among data scientists? Yes. I'm having trouble hearing you. So you want me to explain the difference between affect detection and sentiment analysis? Oh, okay. And you had a second part to the question? Oh, I don't think that would change the architecture. So the difference is sentiment analysis is really just positive, negative, and neutral, and you might have different shades of those. But affect detection is you're looking at things like joy, sadness, anger, embarrassment, and those are really just a different set of labels. So you could use the exact same code and just give it different labels because it's essentially a classification problem. So I wouldn't expect that to change the architecture. And that's kind of the beauty of using the solution, is that you can sort of build any container that does anything and serve it up regardless of the type of problem that it is. It's meant to be heterogeneous. Good question.